Next is the method of by parts. Method of by parts. It is the parallel version of derivative of the product of two functions. The same thing we are doing here. It is the integration of the product of two functions. Say ux and vx are two functions, and we are doing the integration here like this. Ux, vx, dx. So the way to integrate this, that is called the method of by parts, is like this. We will keep one function out of the integral, integrate the second function, minus we will differentiate one function, integrate the second function here, and the product of these two will be again integrated. So whatever we are keeping out in the first term, that we need to differentiate in the second term, and whatever we were integrating in the first term, the same term will be integrating in the second term, and then the product will be again integrated. Ux integration vx dx minus du dx into integration v dx whole integral. Is it okay?
Yes, sir. Okay.
So let us see one example. Integration x sin x. So we can just take x outside. Okay. First, let us take sin x outside. X dx minus d dx of sin x integration x dx. This is a step. So we can say it is x square by 2 sin x minus integration. Here it is cos x, x square by 2 dx. But the problem is that if you are doing this way, means if you are keeping sin x outside, still one integral is left. And in this case, you can see again something like the given one is coming. So nothing simplified here. It is getting more complicated. Right? So if we do the same integration, but now suppose we are keeping x outside, integrating sin x, then let us see what happens. Here it is d dx of x, integration of sin x dx. Now you see it is coming as minus x cos x minus integration. This is becoming 1, and here it is becoming cos x only. Now see, it is more simpler, and in the next line we can just find the value of the integral. That means the order is important here. Which one we are differentiating, which one we are integrating, which function to differentiate, which function to integrate. That thing is, this choice is important here. If you are taking the wrong choice, integration will not be done.
Yes.
Or it can be lengthy. So the thing is that that order or the choice should be done properly. Now, how to do this choice? For this thing, we are having one rule that is called the islet rule. That is called islet. It's a short form abbreviation, you can say. In this term, every single letter is having some meaning. I stand for inverse trigo functions. L stands for logarithmic functions. A stands for algebraic functions. T stands for trigonometric functions. And E stands for exponential functions. And the choice to make is that the more you are going upward, you need to do differentiation. The more you are going downwards, you need to do integration. This should be the choice. So that is the reason x, that integration x sin x dx, what we have done. See, x is an algebraic function and sin x is a trigonometric function. So the more you are going upwards, you need to differentiate. The more you are going downwards, you need to integrate. So that is the reason in case of x sin x dx, we were integrating trigonometric function and differentiating the algebraic function x. Okay, so this way we need to do the integrals. Now sometimes what will happen, some functions are there for which we cannot in that case, say it is integration tan inverse dx, tan inverse x dx. We don't have any formula for this. So these type of functions we can integrate with the help of biparts. And we take it like this. One function we take as 1 and the other function we take as tan inverse. So this is the product of two functions. And obviously 1 is algebraic function and tan inverse x dx, tan inverse x is an inverse trigonometric function. So according to this, you see the algebraic function need to be integrated and the inverse trigonometric function should be differentiated. So according to that, we do the integral here. Say integration tan inverse x dx. This we can write as 1 into tan inverse x dx. Now applying the formula, we can write it like this. Tan inverse x should be differentiated, so it is outside. Integration 1 dx minus d dx of tan inverse x integration 1 dx whole integration of the product. So it is simply integration of 1, so it is x tan inverse x minus derivative of tan inverse x. We
So
know it
1
is
by x
x square and the integration of 1, so x. Now see, this integral we can do easily. Let me write it properly. So it is x by 1 plus x square. We can clearly see that the derivative of the denominator is 2x and we are having one x in the numerator. So we can simply write it x tan inverse x minus half into this. So now the derivative of the denominator is the numerator. So we can write x tan inverse x minus half log mod 1 plus x square plus c. So this is the integration of tan inverse x. Just in the same way, we can integrate other functions also. So say we are integrating log x. Very simple. Again, we don't have any formula for log x, so we can consider it as 1 into log x. So log x is outside because I let L is coming in the second one, A then. So L before A. So L should be differentiated and A should be integrated. That's why log x into 1 dx minus ddx of log x integration 1 dx. That is x log x minus, this is 1 by x, here it is x, so x log x minus integration dA 1 dx again, so it should be only x plus c. So x log x minus x plus c, this is the integration of log x. So this type of functions for which we don't have the second part, we can integrate it like this, taking 1 as the second function. So in the exam, they will see only this thing, that whether you are able to make the choice, which one to integrate, which one to differentiate. Complicated problems will not come, simple problems will come, but you need to make the choice correctly. The next problem is this one, e to the power ax cos bx. E to the power ax cos bx. So here we need to integrate it twice. We need to do by parts twice here. That's why we are taking I here. The integration we are considering as I. Why, you will see later. So this integral we have to do. So let us take the choice e to the power ax cos bx. So exponential and trigonometric. So which should be integrated, which should be differentiated? According to Eilert,
Sir, exponential
exponential should be integrated.
integrated.
So we can write it like this, cos bx is outside, integration e to the power ax dx minus integration ddx of cos bx and integration e to the power ax dx. So cos bx e to the power ax by a minus derivative of this, so it should be sin x here, b sin bx and then e to the power ax by a dx. See, sorry, sin bx will be there. Nothing advantageous is done. It is that much complicated only. So for this reason, we need to again apply the method of bypass for the second term. So we are keeping it as it is, the first term cos bx by a, and the second term we are again integrating using the method of bypass. So the same thing, sin bx is now outside, e to the power x need to be integrated, minus ddx of sin bx is there, and integration of e to the power x is here, whole integral. So let us do it again. E to the power x cos bx by a plus b by a sin bx e to the power x by a minus, here it is now again cos bx is coming, so integral cos b cos bx actually e to the power ax by a dx. Now see, the integrand is the same. If you are taking b by a outside, that is again e to the power x cos bx, but with a negative sign. So that is the thing to note here. Now we are multiplying this here, b by a, and here it should be minus b square by a square. See, integration e to the power x cos bx dx. So this is our I. This part is the same as I. So instead of writing this, we are writing I here. So e to the power ax cos bx by a plus b by a square e to the power ax sin bx minus I, or we can write minus b square by a square into I. So I can be written as, see this line, we are taking 1 by a square common, okay, from the first two terms. 1 by a square common, e to the power, e to the power ax is also there. So e to the power ax by a square, this we are taking common. We are having a cos bx. See, since a is here, so after taking a square common, it should be a cos bx plus b sin bx, and minus b square by a square into I. So from here, we are taking that I in the right hand side, and we can write it as 1 plus b square by a square. After taking I common, and here it is e to the power ax by a square into a cos bx plus b sin bx. So if you take the LCM, you are getting I into a square plus b square by a square e to the power ax by a square a cos bx plus b sin bx plus c. These a squares are cancelling out. So ultimately you can write I as e to the power ax by a square plus b square into a cos bx plus b sin bx plus c. This can be considered as a standard formula. And following the same step, one homework is there, integration of e to the power ax sine bx. And in the same way, the answer should be almost same, e to the power x by a square plus b square into a sine bx minus b cos bx plus c. This is your homework. The next problem is this one. Integration cos of log x dx. Cos of log x. Only one function is there. Cos of log x is one function. It's not the product of two functions. So we need to take it like integration 1 into cos log x. So which one we need to integrate, which one we need to differentiate? So here we need to differentiate this, integrate this.
Differentiate from this.
So cos log x we are keeping outside, integration dx minus d dx of cos log x integration dx whole integral. Again we are taking the same as I, and here you can see it is x cos log x minus derivative of this. So it should be minus sine log x into chain rule. So derivative of log x, so 1 by x into the integration of dx. So this x and this x will cancel out, and you can see it is again coming as one integral plus integration sine log x, just like the previous one. So we need to again integrate this using the y parts. So it is x cos log x is there. Now again integration, so sine log x is outside, integration dx minus d dx of sine log x integration dx, integration of the product. So x cos log x plus x sine log x minus derivative of sine log x. So derivative of sine is cos log x into derivative of log x, so 1 by x into integration of dx, so it is again I. Now it is coming as I. X are cancelling out. So it can be simply written as x common cos log x plus sine log x minus integration of cos log x, which is nothing but I. So it is I is equal to x common cos log x plus sine log x minus I we can write. So simply 2I is being x into cos log x plus sin log x plus c. I is equals to x by 2 cos log x plus sin log x. C. So do some problems on this topic.
Yes, sir.
I think it will not be difficult.